Next, we come to the current transformer rating. The current transformer rating, engineers, is either 1 ampere or 5 amperes. That's your standard. It's either 1 ampere or 5 amperes. We don't have 2, 2.5, 3, or a quarter. It's always the CT ratio that is 1,000 to 1 or 1,000 to 5, 500 to 1 or 500 to 5, 3,000 to 1 or 3,000 to what? Or 3,000 to 5. Great, so what does this mean? The secondary or the transformation ratio is always such that the secondary current is either 1 ampere or 5 amperes. Nice, good. So what did I just talk about? A small part of the transformation ratio, and I haven't talked yet about the other parts, right? The other parts. Okay, let's move on to current transformer grounding. Usually, we see that the secondary side of the current transformer is connected in a star or delta configuration as a 3-phase to feed into the measuring device or our load device, reading 3 currents or 3 connections on 3 phases, red, yellow, blue. And the star point is grounded, right? Per IEEE C527 13.3 guidelines, 2 key points. 1. The current transformer secondary must be grounded to allow current flow, meaning the secondary winding must be grounded to attempt current flow. Number 2, the secondary of the current transformer must be grounded at a single earth point. This means that there must be only one grounding point in the secondary circuit of the pilot's attempt. In this video, we will only talk about the first point, which is why the secondary coil of the pilot's attempt is grounded. First, from a safety point of view, it is considered to protect the people who deal with the city circuits and to protect the equipment connected to the secondary circuits of the city, whether protection devices or metering devices. CT, whether they are protection devices or metering devices. Secondly, in the case of wire loss or an open circuit in the CT secondary, a transient overvoltage will occur on the 3 phases. However, when I have a grounded neutral, I maintain the neutral quality at 0. Thus, the amount of insulation needed in current attempts is much less, and consequently, the cost will also decrease. The third point is that there is stray capacitance between the primary and secondary, and of course, between the primary and ground, and between the secondary and ground. This will lead to the presence of electrostatic charges, which is safe for people working on the CT rotor. Additionally, it may result in induced voltage from the primary to the secondary, which means high voltage that could damage the equipment connected to the CT secondary.